Hey everyone, welcome back to my YouTube channel. I am Maurya. I am pursuing my MBA in Sri Venkateswara Engineering College, Bangalore, and I am here with my new topic in statistics. Then my topic is probabilities. And before going to the topic, welcome back everyone once again. And the first one is introduction to probability. Probability is just a study of the likelihood of events occurring in it helps us understand and quantify uncertainty, uh, enabling informed decision making across diverse fields with finance, science, and everyday life. And the next one is definition and concept. There are three concepts, that is sample space, event, and probability. The first one is sample space, the set of all possible outcome in an experiment or an event. It is known as a sample space. And the event is a subset of the sample space, representing a specific outcome or set of outcomes. It is known as an event. And the other one is probability, a measure of the likelihood that an event will occur, expressed as a number between 0 and 1. It is known as a probability. And the next one is types of probabilities. Theoretical probability calculated based on the ratio of favorable outcome to total possible outcome, assuming a fair and unbased experiment. The next one is emp- empirical probability, determined by conducting experiments or observing real world data to estimate the likelihood of an event occurring. Next one is the conditional probability, the probability of an event occurring given that another event has already occurred. And the other one is uh, theoretical probability. First one is equally liked outcomes. Uh, Theoretical probability assumes that all possible outcomes in the sample space are equally likely to occur. And next one is ratio of favorable outcomes. The probability of an event is calculated as the ratio of the number of favorable outcomes to the total number of possible outcomes. The other one is mathematical modeling. Theoretical probability is based on the mathematical models and principles, making it useful for predicting the likelihood of events of controlled experiments. Next one is uh, empirical probability, experimental observation. uh, it is determined by conducting experiments and observing the actual outcome rather than uh, relying on mathematical modes. Relative frequency, it is calculated as the ratio of the number of times an event occurs to the total number of trials or observations. And real world applications, uh, it is used for making a decision based on actual data, particularly in a field like statistics, finance, and risk management. The next one is limitations. It can be affected by sample size bias and other factors, so it's important to consider its limitations. And the next one is conditional probability. First condition is dependent events. Conditional probability deals with the likelihood of an event occurring, uh, given that another event has already occurred. uh, Intersection of events, the conditional probability of event a given event B is calculated as the probability of the uh, interaction and a and b divided by the probability of b. The next one is Bayes theory. Bayes theory provides a way to calculate conditional probability and update beliefs in a light of a new information. The next one is Bayes theory. Prior probability, the initial belief or understanding of an event's likelihood before considering new information. And next one is likelihood, possibility of an observing the new information given a particular hypothesis of or event. The next one is posterior probability, the updated belief or probability of an event occurring after considering the new information. Bayes theory, the mathematical formula that relates the prior probability, likelihood, and posterior probability. The next one is applications and examples. Medical diagnosis. The medical diagnosis is using Bayes theory to estimate the probability of the disease given test result. And next one is finance and investment, calculating the likelihood of stock price motivating or economic events. Artificial intelligence, implementing Bayes network to decision making and pattern recognition. And the next one is risk assessment, evaluating the probability of an natural disasters, accidents, or the events. And the last one is conclusion. Understanding uncertainty. Probability provides a understanding the uncertainty in inheritance in the world around us. The wider spread applications, the principles of probability have a wider range of applications for scientific research to everyday decision making. And continuous advancements as over understanding a probability continues to evaluate it will play an increasingly important role in the shaping or further. And thank you for watching my video, everyone. Thank you.